All right, so I had some people ask me in class, they weren't able to come, but they wanted me to go over the qualitative graphs. That is, looking at a graph and being able to describe what's going on in that situation. And you'll need to be able to do that. Sanders, right? Yeah. So I just wanted to spend a few minutes going over that. That's something I wanted to go over anyway, because you're going to see 3 or 4 questions like that. So you need to be able to do this in several situations. Like, for example, if I give you a situation where, what would I do? Well, like if I give you an x versus t graph, say an x versus t, it looks like this. And I want you to be able to describe several things about it. First, I might just ask you just to describe in words what this object is doing. Is it speeding up, slowing down, traveling in the positive or negative direction, and what kind of acceleration does it have? And the way you'd go about that is you'd look at the slopes. This one starts out with a big negative slope and ends up with a small negative slope. So it's slowing. It has a negative velocity, and because of that, if it's slowing down and it has a negative velocity, let's see, I always get confused about this. So in order for it to be slowing down, the acceleration and the velocity have to be in opposite directions. And in this case, it's slowing down, the velocity is negative, so the acceleration is going to be opposite that. So it's going to be a positive acceleration. Positive acceleration does not mean speeding up. It means that it's changing velocity in the positive direction. And so it's a little bit different than the way you think of acceleration. You also need to be able to identify or draw the v versus t graph. And I'll always give you, a 2-quadrant graph like this for v versus t. And in a v versus t, I start out with a big negative and end up with a small negative. So it's going to start here and go here. So that graph would look like that. Okay, so you need to be able to start from a position versus time. Let me give you one more. And be able to describe that motion and then translate it into a velocity versus time. Or hey, I'll tell you what, let's go the opposite direction. We will start with a v versus t and go to an x versus t. Let's try that one. So it starts out with a positive or negative velocity. It's positive, and it's positive because it's in that first quadrant, right? This is 0 right here. This is positive. This is negative. And so right here, that's a big positive velocity. So initially, your graph is going to have a big positive slope. So it's going to have a big positive slope like that. And then down here, it's going to have a small positive slope. So it'll look like that. So my graph will look like that. You can tell, I hope you can tell right away what kind of acceleration do I have in this situation. Positive or negative? It's negative because the slope is negative. The slope of a v versus t graph gives us our acceleration, so that is a negative acceleration. But I could tell too from this x versus t, I have a decreasing speed, it's slowing. The velocity is positive because this slope is positive here. And that means if it's slowing down, the acceleration is opposite the velocity, so I have a negative acceleration. Okay? I'll give you also physical scenarios. Like, for example, we did this in class today. But if I give you, say, a ball that goes up and then comes back down again, you're going to have to draw the v or the x or y versus t graph for this. So just make sure that you know how to do it. This is going up and coming down, so it's sort of 2 parts. The v versus t graph, big positive velocity, goes to 0 at the top right here, and then goes in the negative direction. And then the y versus t, what's the y? It's always a positive y. Starts out with a big slope, goes to a 0 slope, ends up with a big negative slope, so it's going to look like this. It's an inverted parabola. Okay? What else? What would you do with that? Well, I would have you do the quantitative graphs, but that's better if we look at some sample test questions. Are there other particular questions that you want me to go over? while you're thinking, let me remind, are you about to say something, Chance?
Kinematics.
Like for the free response?
Yeah, like the word problems.
That's what I was about to do. So with the free response, you're going to have 2 kinematics problems, but they're going to count for 6 questions. Okay, because the first one's going to be 4 questions. It have 4 parts, each is a separate question, and then the second one is going to be 2 questions with 2 parts. The first one's going to be a free fall problem. Likely it's going to be one like this, but it could be one where I'm just dropping a ball. But those are very similar problems. We've worked through both of them. So let's go through this one right now, where I have something that goes up, it goes up to the top, it stops, turns around, and comes back down. So let me just step through. Well, let's see. I'll just give you some numbers. So let's say V here is 20 meters per second, and I want to know the maximum height. I want to know how long it's in the air, and I want to know, well, right now, the maximum height and how long it's in the air. How long is it in the air? Now, the acceleration is 10 meters per second per second. For every second, the velocity changes by 10 meters per second. So how long, don't even think about formula, how long does it take this guy to go all the way up into the air? 2 seconds, because every second, the velocity will change by 10 meters per second. It starts out at 20 meters per second. After a second, it's at 10 meters per second. And then after another second, it's at 0 meters per second. So that's how long it gets to go up in the air. Now we can describe that in a formula. V equals V naught plus AT. And so we have 0 equals 20 minus 10. That's our acceleration times t. And so t is equal to 2 seconds. That's the time where? At the top, right? So the time at the top is 2 seconds. That means the total time is 4 seconds. 2 seconds go up, 2 seconds go down. I'm sorry if this is, I know like some of y'all have this, and I'm glad. That's going to be good. That's 4 questions that you'll have under your belt, starting right at the beginning. But I want to make sure everybody gets it, okay? So y'all bear with me. If I want to find y, then I would use my position equation. Y equals V naught t plus 1/2 AT squared. So that's going to be, well, I know t now. I'm going to use 2 seconds because I want to use the time at the top. And then that'll give me the position at the top. Okay, so I get 20 times 2 minus 5. Half of negative 10 is negative 5 times 2 squared. That's 40 minus 20. That's 20 meters. So it goes up a distance of 20 meters. It won't always be the same as the initial velocity. Here it just sort of happened. Like if it was 30 meters per second, it wouldn't be 30 meters. So that's just a coincidence. What would happen? What would I get for my position if I put in 4 seconds? Would I get a bigger y? What would I get for the value of y if I put in 4 seconds? I'd get 0 because I know at 4 seconds it's back here. And so if I put in 4 seconds, then that's what I'm going to get. I'm going to get 0. If I put in something bigger than 4 seconds, then that means that the ball is traveling down further and you get a negative value. Okay, we'll get into that in the next test. We're not too worried about that right now. 4 questions. Yeah.
Okay. This one you know.
Wendy. Okay, go ahead.
When we did one like this in class, like the word problem, it
Uh-huh.
was hard for me.
Okay, let's look at the word problems. Yeah. So, so don't look at that first test. Goodness, look at this test. I was telling one of our new faculty who's about to give his first test that don't make the mistake that I made. Look at this test. It has 42 questions. That would be a hard test, don't you think? I think 28 questions is pushing it for the time. It was a tough test. Like students, I didn't know what I was doing. That was the problem. But I told them that I think that almost every student walked out of that room crying because of this test. It was terrible. It was like the worst test ever. But we figured it out. We figured out what we were doing. I'm just going to go down the later test. Well, so this, I mean, for example, this is the problem that I just worked, right? A guy throws a ball up into the air at a speed of 20 meters per second. That's my V naught right here. Neglect air resistance. What is the maximum height? That's Y. That's the problem. That's the same one that I just worked. And so I know that the maximum height was 20. That's what we just found. Okay. Let's see if there's some others. Let's look at number 15. This is a good question. It's not a free fall problem. It's a kinematics problem. But it's good because you have to read it and then think about it. Now, you'll have kinematics problems in the free response, but you'll also have them in the multiple choice. So don't think that's all the kinematics you're going to see. You're going to see 2 or 3 others in the multiple choice. So you're right, Wendy. Part of the problem in reading these questions is just knowing how to read them and knowing what the information is that you have that's given. A car initially travels at 10 meters per second. I read that and I think right away, okay, initially, that's my initial velocity. So that's 10 meters per second. The driver sees a traffic light ahead and steps on the brake, so he slows down at a rate of 2 meters per second squared. So A is equal to 2 meters per second squared. But I need to take into account that he's traveling in the positive direction with V naught. And if he's slowing down, that means the acceleration is opposite the velocity. Negative acceleration is not always deceleration, but in this case it is. It requires 5 seconds for the car to stop. T is equal to 5 seconds. What distance does the guy cover in this time? And I want to know what is X. Okay, so now that I have it all written down, if I'm looking for X, it actually turns out to be a pretty simple question because the only equation I have for X is this one. And I have everything that's there. 10 times 5 plus 1/2 of negative 2 times 5 squared. That's 75 meters. Oh, keeping 1 sig fig is the answer is going to be 80. Okay? That's a good question. You could see something like that. Not identical to that, of course, but something like that. Here's another free fall problem. This could be the other type of question you'd have in your free response. I drop a ball 12 meters from the floor. How long does it take the ball to hit the ground? I like to draw a picture. This is a distance of 12 meters. I have an acceleration equal to negative 10. This isn't stated, but I know that V naught is equal to 0 because I'm just dropping it. I'm not throwing it down. And I want to know the time. Well, I always like to write my equations. And look, when you get your test, you'll have a form, and it'll have like a block in it. There'll be some bubbles over here. Y'all saw the video I sent out, right? You'll be able to write in that block. And what I recommend is that you just, if you have trouble remembering those 2 equations, or if you have trouble remembering your sine, cosine, tangent, all that business, that you just write those things in that box as soon as you get your test, okay? And that way you have it there right in front of you, and you're not making mistakes throughout the exam, that you can make sure that you got it right, written right there, and then you'll have that as a reference. So it's like making your own little equation sheet, okay? But remember on my form, you only write in this block, okay? You don't write elsewhere. You can bubble the bubbles, but don't write elsewhere. It messes up my, my scanner. Oh, so I'll have my equations, and then I would know that y is equal to v naught t plus 1/2 at squared. Do I know everything here? I think so. I'm just looking for t. So y is 12 equals 0 times t plus 1/2 of negative 10 times t squared. I hear whispering out there. No whispering. Just hang with me, okay? Now, this goes away, and I get 12 equals negative 5t squared, and so t is equal to the square root of 12 over negative 5. I have a problem, right? What's my problem? I can't take the square root of a negative number. What did I do wrong? The negative 10, right. So, or negative 12, rather. The negative 12. This should be a negative value because this is y not equal 0. And so this is y equal negative 12. That we don't really talk about it in this way, but that's my coordinate system. That's where I'm setting my frame of reference. We haven't talked about that a whole lot in this chapter, but it'll come up again in chapter 4, and we'll talk more about that. Okay, so I actually have a negative right here, and the square root, roughly square root of 2. I think the answer is probably D. I don't know what that is exactly. Okay? Yeah. Oh, hey.
Can you go up to number 4?
Number 15?
Yeah, why aren't you subtracting from 50?
Oh, I should. Yes. So it would be 50 minus 25. Yeah, so the answer would be 50. Yeah, I'm sorry.
By the time I looked at you said the answer, and I was like, wait.
Yeah.
See how you got it.
Okay, y'all see what? Be careful, because you can make little mistakes like that. And as I told you, Jacob,
30.
huh?
But when it be 30, it's 50 minus 25.
Y'all are sticklers for details, huh? Remember, as I told you, that on the test, just because you get an answer does not mean that it's the right answer. So I know that's a little frustrating for you, but hey, that's life. That sometimes we make mistakes, and it seems like it's the right answer, but it's not. So I know what mistakes you make, just like I know that I was going to make that mistake. Actually, I didn't know that I was going to make that mistake, but that's a common mistake that you make. And I'll go through and pick answers that are common mistakes. So don't think that just because you got an answer that you got it right. Okay? I say that with a smile. Yeah, Ariel?
Back down to 16. Why is that 12 negative?
The 12 is negative because this point right here, where the ball is initially, is y equals 0. And since down is negative y, my y final, which is down here, is in the negative direction. So if you think about, this is my xy coordinate system. This is plus x, plus y. This is minus y in this direction. And since it's down, it's negative. But again, you would have, if you didn't set it at negative 12, you would have run into a problem here because you would have been trying to take the square root of a negative number. And if that ever comes up, just say, oh, one of my numbers must have to be negative. That maybe I didn't use my acceleration as negative, or maybe my position I didn't use as negative. Just go back and revisit it. Okay? You're going to have to also do ones like number 18. This is going to be a free response, where I give you a v versus t or an x versus t graph, and I ask you to find the velocity and or the distance, okay, or the position. Like, for example, if I gave you an x versus t, I would probably ask you what is the velocity. In this case, oh, this one was easy. What's the answer to this one? At 3.5 seconds, which is right here. It's 0, right? It's 0, right? The slope of that line is 0. I say it's easy. It's not easy if you don't know how to do it, or even if you just sort of know how to do it and you haven't practiced very much, then it's not very easy. But if I asked you, say, what is the velocity right here, I would find the slope of this line. And the slope of that line is a triangle here and here. This is -6, right, because it's 4 to -2. -2 minus 4 is -6. And here I'm going 1 to 2.5, so it's 1.5. So the slope there would be a -4. Yeah? Y'all can do that? It's a free response. So I don't want no secrets. I want y'all to know what to expect on the free response. Okay? That's sort of like what I do. Okay, and then if I give you an x versus t graph, you would have another question. I wouldn't ask you the distance, but it would be sort of a simple question like, hey, what is the position at t equal 1.5 seconds? And then it's really just a matter of reading off of the graph. So this is 1.5 seconds. The position at t equal 1.5 seconds is 2 meters. Now, if it was a velocity versus time graph, I would ask you the distance traveled between 2 times, in which case you'd find the area under the graph. We'll see if we can find one of those as we come upon it. Any particular questions, y'all? Maddie?
Oh, I remember one of those guys.
Which one?
2017, and it's number 15.
By the way, if you get into vectors, we're not having vectors. So, yeah, number 15. I'm trying to think if we talked about this. I don't think we talked about this. We're going to get into it in chapter 4, so I didn't really touch on it. But the answer is that it doesn't matter what the mass is, that your acceleration is always the same. So you could have a 100-pound mass or a 2-pound mass, and it's always going to have the same acceleration. Would I have a good example here? No, I don't have a heavy thing and a light thing, but they follow at the same rate. Okay. Let's look at 19. Like 19. I love these questions where there are multiple answers that you have to sift through. Describe the motion of the object for these 3 time periods. So on these, where I give you lots of options, it really becomes sort of a process of elimination. And in fact, that's good practice on multiple choice exams, standardized exams, that you go through and you look for the answers that just don't make sense. So in this first one, the object has positive acceleration. I'm just looking at A right now, looking at the statements for A. The object is slowing down, the object has a negative acceleration, or the object has a negative velocity. Does this object have a positive or negative acceleration? It starts out with a positive velocity. It goes to a slower positive velocity. What's the acceleration? It's slowing down or speeding up? Slowing down. Is the velocity positive or negative? Positive. So that means the acceleration, if it's slowing down, is opposite the velocity. So it's a negative acceleration. So that gets rid of this one already. The object is slowing down. It could be B or C. It's not D. Like we've already said, it has a positive velocity. And now let's look at the second one. For B, the object is speeding up, or the object has 0 acceleration. Which of those statements is true? It has 0 acceleration. Be careful, because this is position versus time, and the slope of a position versus time gives us the velocity, and the slope of this guy is constant. That means that the velocity is constant, so the object is not speeding up. So the answer has to be C. So you see how I have this problem, and it has 12 different things that I'm supposed to do, but I really could do it just by sifting through them pretty quickly. I don't have to look at each individual thing. You want to be good at that, not just for this class, but other classes, and later when you do the MCAT or the GRE or the PCAT or whatever it is that you do, that you be able to sift through answers well. Okay? Yeah, Victoria?
15. It says like which one has a greater velocity, and then it said acceleration.
Oh yeah, so they both have the same acceleration, so they're both going to have the same velocity. Yeah. I think that might have been in their concept test, but I think we skipped over them. We're going to come back to it later when we do chapter 4 on forces. Okay? So you won't see a question about mass. In fact, if I ever give you a mass on this exam, mass is not relevant to any of the stuff that we're doing. Did y'all hear what I said? Like if I give you mass, which I sometimes do, like I like to give you extra gifts. Just extra information that you might want to use for something later down the road. But it might not be relevant to the exam at all. Okay? So if I give you a mass, you're not going to need it. It's just sort of extra stuff. Did y'all hear what I said? Okay. Don't be thrown off by that. You want to look at some chapter 1 stuff? We've done a lot of kinematics and graphs and stuff, or we can look more at graphs. Kinematics. What do you want to do? You want to do graphs? Okay. Was chapter 1 easy? Okay. It's not easy if you don't know how to do it. And you don't really know if you know how to do it until you've practiced it a bunch of times. So make sure that you're practicing. Let's see. I like number 23. So probably see something like this on the free response, where I give you a V versus T, and I ask you a couple of things, like I do here on 23, 24. I think it was just these two questions. Here I want to know, what is the distance the object moves between 0 and 10 seconds? I don't have a grid on this, so the easiest way is just to draw two shapes. I have a triangle there, a rectangle here. The rectangle is 6 by 12. Right, I have 6 units down here, 4 to 10. I have 12 units here, 0 to 12. This triangle has a base of 4 and a height of 12. And so what is the area of a triangle? Well, let's see. A triangle is effectively half of a square. So it's going to be like half of length times width, or half of base times height, right? Y'all know the area of a triangle? Yeah, so it's half of 48, or 24. 6 times 12 is 72. So that's 96 meters. So he traveled 96 meters. And then what is the average acceleration between t equal 2 and 8 seconds? I'm going to erase all this. Between 2 and 8 seconds, 2 seconds is right here, 8 seconds is right here. Effectively, you're taking the slope of this line. But you can think of it too as VF minus V naught divided by delta t. That's going to be 12 minus 6 divided by 8 minus 2. Let me show you where I got those numbers. 12 minus 6. 12 is this point. 6 is that point. 8 and 2. 8 is there. 2 is here. That's rise over run, right? 6 over 6. So my acceleration is 1 meter per second squared. That's my average acceleration. Okay? Free response. Oh, that's vectors. Car has negative acceleration and positive velocity. Which is it? A, B, C, or D? Well, the acceleration is kind of hard to do. Like, you have to think about it. But you can get rid of some, because I'm only looking for ones with positive velocity. Which ones can I get rid of? B and C. That one has a negative. That one also is negative. And now if it has positive velocity but negative acceleration, is this thing speeding up or slowing down? It's slowing down. And which one's slowing down? D is right. Man, y'all are awesome. Were all the ones that were getting all the questions right today? Were you? No? It's okay today, but Monday I want everybody to get every question right. That would just make my day if we had 100% average. Wouldn't that be awesome?
Just fudge some numbers and we'll all have it.
Huh?
I said just fudge some numbers and we'll all have it.
No, I have to be honest. Y'all are honest. Y'all don't want me to give up my integrity. Okay. Number 18, you drop an object. Which of these represents the position versus time? First of all, if I drop an object, does it have positive or negative velocity? Negative is going down, so I can get rid of the positive ones. A is positive. Which else? D is positive. Is C. The answer is C. It starts out slow and it speeds up. Let's look at 14. On some of the old tests, 14 is a good question, but on some of the old tests, I used to use this online homework system, and part of the incentive for students to do the online homework is that I would give 1 or 2 of those questions on the exam, and that's what this was. So sometimes if you find a question that just sort of looks a little bit out of place, that's why. It's because it was in the online homework, so the students got to see it beforehand. But let's look at it. It's a good question regardless, because it requires you to read through it and think about it. This swan runs along the surface of the water until it reaches a certain velocity, and then it can take off. And I want to know how far it travels. So the initial velocity for this swan is 0. Right? It starts out at rest, and it starts running along the surface of the water, and then it reaches a final velocity equal to 4 meters per second. And then it has an acceleration equal to 0.2 meters per second squared. It's speeding up. The velocity is positive, so the acceleration is also positive. And I want to know how far it travels. Oh, x. I want to know how far it travels before it reaches that speed of 4 meters per second, at which time it can become airborne. Okay? So, in order to solve this, I don't really know. I have to write down, I'm going to write down my equations. So I have V equals V naught plus AT, and then X equals V naught T plus 1/2 AT squared. You would have had this already written on your little equation sheet. What don't I know? I don't know X, and I don't know T. I don't know T here. Okay, so it looks like the approach that I'll take is I can take this and find T, and then whatever I find for T, I'll plug in over here, and then I can find X. So it's not a system of 2 equations, but it is it's a 2-step problem, and you can see that in the free not in the free response, in the multiple choice. So I solve for T first. V is 4. That's equal to 0 plus 0.2 times T. And so T, wasn't it 0.2? Yeah. T is 4 divided by 0.2. That's 20 seconds. So it takes 20 seconds for this swan to reach 4 meters per second. But then I really want to know how far it goes. So I say X is equal to 0, because V naught was equal to 0, so this whole term just goes away, plus 1/2 of 0.2 times the time, which is 20 seconds squared. So that's 0.1 times 400, or 40 meters. Okay? That's fair game for the exam. Let's see if I can find one just like we were talking about today. You'll be thinking, if you have particular questions, holler. I know you can't see this, but I can. Sort of. I don't give many systems of 2 equations, but I think I have before. Any particular questions you'll have come up? Okay, give me just a second. Oh, look, I think this is one. Let's try it. So what exam is this? Fall 14, number 21. Is that right? Yeah. Yeah, this is a system of 2 equations. Number 21. You guys ready? You want to take a look at it? This is like something like what you'd have for your free response. The very first question that you'll have. Or no. The second question that you'll have. Not exactly like this, but something similar. A truck covers 100 meters. So X is equal to 100 meters in 10 seconds while smoothly slowing down to a stop. What is his initial velocity? So V naught, I don't know what that is. I also don't know what A is. Right, the acceleration is not given. I know it's stopping, but I don't know what the acceleration is. Is there anything else that I know in this problem? I know the final velocity, right? So I know that v final is equal to, it comes to a stop, so it's equal to 0. So look, I have my two equations, x equals v naught t, v equals v naught plus at. Let's see what my unknowns are, v naught and a, v naught and a. Oh shoot, I have two unknowns in each equation. I'm sorry, did that offend you? I have a potty mouth sometimes. Shoot. Okay, so I know y'all like to put numbers in. That's okay. Let's do that. These are fairly simple, so I think it's okay. So I have 100 meters equals t is 10 v naught plus 1/2 of a times t squared. So that's going to be 50 t or 50a. Because t is equal to 10, half of 10 squared is 50. Go with me? Now, I can simplify this. No, let's look at this other one. I have v is equal to 0. That's equal to v naught, which I don't know, plus 10a. Okay? The easier way for you to approach these problems is going to be to look at this second, the velocity equation. Just because there's no squared terms in it, it's just sort of an easier equation to deal with. There's no coefficients for the v naught. So here I have v naught is equal to negative 10a. So I can take this, which I know is equal to v naught, and plug it in there. So I have 100 equals 10 times negative 10a plus 50a, and that's something I can solve. So I have 100 equals negative 50a, so a is equal to negative 2. So that's my acceleration, and then I can take this and plug it in over here, and my v naught is negative 10 times negative 2, which is equal to positive 20. So those are my two answers. The acceleration is negative 2. The velocity is positive 20. It's really just the math. I just want to make sure that you can solve this system of two equations. Can y'all solve a system of two equations for me on Monday? Yes? Okay, I know it's a challenge for some of y'all. It's been a while since you've done this, but it's important when we move into Chapter 4 that you be able to do it. All right? What else, folks? Free response. Two questions, right? If it was this question, it would be what is V naught, what is A? So it's sort of a freebie that because the two answers are dependent upon one another. Are you going to show your work on the free response? Absolutely. Because if you don't show your work, not getting anything, okay? Like that's easy for me too. If you don't show your work, if you just write an answer, not going to be cool. On the graphs, when you're showing your work on there, just show me where you calculate your slope. Show me how you calculate your slope. You don't have to write out a big old essay about how you did it. I just need to be able to see your work. Okay? In fact, you don't want to write out a big essay. You want to kind of move through it as quickly as you can, but show enough that I understood what you did. You going to spend a little bit of time on Chapter 1 or more time on this? Don't tell me what you want. I'm going to go to Chapter 1. Yeah, I'm going to go to Chapter 1. So you're going to have two trig questions. I'm going to ask you for an angle. I'm going to ask you for a side. I'm going to give you a triangle like this. I'll ask you for the side, and I'll ask you for the angle. Notice, like here, I drew the angle up here. That's okay. Like we can put the angle wherever we want. And you have to be able to find the angle. So in this case, you have the side adjacent to the angle, and you have the hypotenuse. So, ka, to, so I'm going to use ka, right? Because I have A and H. So I'd say cosine of theta equals 5 over 7. And so theta would be the inverse cosine, or the arc cosine of 5 over 7. You're going to have to do dimension. Oh, and then to find x, I would do the a squared plus b squared equals c squared. be careful. Sometimes students forget to take the square root. And of course, that's an answer, right? Not taking the square root. So make sure that you do the 5 squared plus x squared equals 7 squared. Then in the end, you don't forget to take the square root of x squared, both sides. It's not that students don't know that. It's just in an exam, you're kind of rushing, you're a little bit flustered, you're not so sure about the previous problem, and then you let that spill into the next problem, and then you begin missing things that you really shouldn't be missing at all. Because y'all know Pythagorean theorem. I know you know it. It's just sometimes in an exam, things that you know, they just fly out the window. And we want to keep all that in the house. You're going to have to do, say, something like 11. Or maybe not something like 11, but a dimensional analysis. So here, I just want to know the units of this equation. So I have V mx over A. V is meters per second. M is kilograms. And you can put it over 1 if you want to keep everything in fractional form. I think that's probably not a bad idea. Meters over 1. And then acceleration is in the denominator. And so when I write it, I'm going to flip the units and bring that A up into the numerator, because 1 over meters per second squared is equivalent to second squared over meter. Like 1 over half is 2 over 1. And so that would give me, that cancels right there with there. That cancels with one of these, and I get meter kilogram seconds. So D is the right answer. You need to know your meter, centimeter, and your kilogram. A centimeter is about the width of your pinky. A meter is about 3 feet, and a kilogram is a little over 2 pounds. Okay? So usually I like to ask an area or a volume question. Y'all seen these on my old tests. I know you have. So it'll be something that you're familiar with, that you can see in your head, and it might even be something that you just know right away what the answer is. But you might also have to think about it a little bit. Like I say, okay, well, how many centimeters is that? And you might get an answer that's different from my answer, but you're not going to get a wildly different answer. You're not going to be off by a factor of 10. Okay? So look for the answer that's closest. Let's see what I did here. Oh, well, that was which of the following weighs about a pound? Which is it? Which is about a pound? Right, a half a kilogram. You need to know your standards, but be careful, because sometimes I'll ask you for standards, but I just sort of mix them up a little bit. Like I'll say, the standard for time is based on the speed of light. That's not right. That would be a fine standard for time, but that's not the standard for time. I might tell you the
Kilogram changed since the last.
And the kilogram changed, right? So all the old tests, kilogram changed last fall, like in November of last year. So remember, the kilogram is now based on Planck's constant, not on a cylinder. And in fact, in some of them, you'll see, yeah, like for number 4 here, last year they were talking about a different standard. It turned out they didn't go with that standard, but everybody thought that they were. And then, those measurement scientists, boy, they are a wild and crazy bunch. They decided to just go off in the left field with the whole Planck's constant. Okay? But it's the Planck's constant for the kilogram. You need to know how to do this sort of thing. You need to know how to convert units that are powered. So 12 meters per second squared to miles per hour squared. You just go by each unit. So in 1 hour, there are 3,600 seconds. Because the seconds is squared, you have to square the conversion factor. And then meters to miles, in 1 mile, there are 1609 meters. And I give you that conversion factor here. You don't square that, though, because the meters are not squared. And the way that I know which to put on top is that I want it so that the meters cancel. I'm left with miles per hour squared. The seconds cancel. I'm left with miles per hour squared. Sig figs. You have to, if you add numbers, you keep the lowest number of decimal places. And I would follow this first because it's in parentheses. So that would be 5.0 squared divided by 2.54. And then I would square that number. It'd be 25. I kept 2 sig figs because that's what 5.0 had, divided by 2.54. And now I have 2 numbers. One has 2, one has 3. I'm going to keep the lowest number of sig figs. And so I would keep, when I'm multiplying or dividing, keep the lowest number of sig figs, and that would be 2. You'll have one question like that. You'll have one units question where you have to convert units, one sig fig question where you have to do sig figs. You're going to have 2 or 3 dimensional analysis questions where you have to look at the equation and tell me what the dimensions are, or tell me if they're dimensionally correct or not. Look at this one. Can you tell me right away which of these equations is dimensionally correct? Which one, Romy? The first one, right? That's one that we've seen before, right? So I don't even really need to think about that one because I got it right there on my little bubble form. I was like, oh, yeah, I already know that one. I don't even need to look at that. But then I go and I look at the other 2. Trig, estimation, displacement. Y'all know how to do the displacement, right? So displacement from A to B is going to be -1 minus 3. Final minus the initial position. So it's -4. Position versus time graphs, average velocity, we did that already. Instantaneous velocity at t equal 8 seconds, that would be the slope of this line, rise over run. Watch your, don't count the squares, look at the axes. All right, there's a kinematics problem. Graph, I think we did that one already. All right, any other particular questions? I'm going to stop if y'all are, I'll stay here for another hour if you need, but helpful for you people? Yeah? I want you to do well. I really do want you to do well. But if you weren't doing well in those questions today, which about half of you weren't, you need some more review. Okay, you need some more practice. If you weren't doing well in the questions that I gave you today, I said about half of you weren't. And so I'm a little concerned, a little bit concerned, but it's going to be okay because I know you are going to catch up over the weekend. I'll check my emails over the weekend. If you have any issues, let me know. We can chat on the phone. I won't be able to come to campus, but I can talk you through whatever you're doing. Okay? Have a good weekend. Viewed it. If I did.